high leg of a 120/240 delta 3-phase service can indeed cause trouble for a 240-volt 1-phase X-ray machine if it is improperly connected. In a delta 3-phase system, the configuration involves 3 phases that are 120 degrees out of phase with each other. The voltage between any 2 phases measures 240 volts, while the voltage between any phase in the neutral conductor is 120 volts. The high leg, also known as the wild leg or stinger leg, is the phase that is 180 degrees out of phase with the other 2 phases. It exhibits a voltage of approximately 208 volts to neutral, and 480 volts when measured against the other 2 phases. If the X-ray machine were to be connected to the high leg and the neutral, it would receive roughly 208 volts. However, if the X-ray machine is inadvertently connected between the high leg and one of the other phases, it would then be subjected to 480 volts, which is significantly excessive and poses a substantial risk of damaging the machine. To mitigate this potential issue, it is crucial to ensure that the X-ray machine is connected to the correct phases. The recommended approach is to connect the machine to 2 of the 3 phases while omitting the neutral connection. Failure to adhere to proper connection procedures can lead to damage to the equipment and potential safety hazards. Furthermore, depending on the specific voltage requirements of the X-ray machine, a transformer might be necessary to convert the available 240 volts to the required voltage level. If the transformer is not adequately sized or properly connected, it can also contribute to operational problems for the machine. It is imperative to engage a qualified electrician who possesses a comprehensive understanding of the X-ray machine's electrical specifications and the building's electrical system to oversee the installation process. This ensures that the machine is correctly connected and that all necessary safety precautions are implemented. Understanding the intricacies of a high-leg delta system is crucial for safely connecting equipment. Firstly, the high-leg delta configuration is characterized by one phase having a higher voltage to neutral than the other 2 phases. Secondly, this higher voltage can be problematic for equipment designed for standard single-phase voltages. Thirdly, proper identification of the high leg is essential. The high leg is typically marked with orange tape or paint. The voltage from the high leg to neutral is approximately 208 volts, while the voltage between the other 2 phases and neutral is 120 volts. The voltage between any 2 phases is 240 volts. Fourthly, equipment that requires 240 volts should be connected to the 2 phases that provide 240 volts phase to phase. Do not connect to the neutral. Connecting to the high leg and neutral will result in an overvoltage condition and damage the equipment. Fifthly, transformers can be used to step down the voltage from the high leg to a usable voltage. However, the transformer must be properly sized and connected. Sixthly, it is important to consult with a qualified electrician to ensure that the equipment is properly connected. An electrician can identify the high leg and make sure that the equipment is connected to the correct phases. Seventhly, failure to properly connect equipment to a high leg delta system can result in damage to the equipment, fire, and electrical shock. Safety should always be the top priority. Eighthly, when working with electrical systems, always turn off the power at the breaker before making any connections. Ninthly, use appropriate personal protective equipment, such as gloves and safety glasses. Tenthly, if you are not comfortable working with electrical systems, contact a qualified electrician. The NEC, or National Electrical Code, provides guidelines for safe electrical installations. Article 110.3 B covers the installation and use of equipment. It states that listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. Article 210.6 C1 covers voltage to ground. It states that for a grounded system, the voltage to ground shall not exceed 150 volts for circuits supplying luminaires or portable or mobile home equipment. Article 215.9 covers ground fault protection for equipment. It states that ground fault protection of equipment shall be provided for solidly grounded wire electrical services of more than 150 volts to ground, but not exceeding 1000 volts phase to phase for each service disconnecting means rated 1000 amps or more. Article 230.95 covers ground fault protection of equipment. It states that ground fault protection of equipment shall be provided for each service disconnecting means rated 1000 amps or more on solidly grounded wire electrical services of more than 150 volts to ground but not exceeding 1000 volts phase to phase. Article 250 provides requirements for grounding and bonding. It is essential for electrical safety. Article 300.3 covers conductors of different systems. It states that conductors of different systems shall not be installed in the same raceway, cable, or enclosure unless permitted elsewhere in the NEC. Article 310 covers conductors for general wiring. It provides ampacity tables and requirements for conductor insulation. Article 408 covers switchboards and panel boards. It provides requirements for the construction and installation of switchboards and panel boards. Article 430 covers motors, motor circuits, and controllers. It provides requirements for the protection and control of motors. Article 450 covers transformers. It provides requirements for the installation and protection of transformers. Article 517 covers healthcare facilities. It provides special requirements for electrical systems in healthcare facilities. Ensuring the proper connection of electrical equipment to a high-leg delta system requires careful attention to detail and adherence to safety guidelines. The consequences of improper connections can be severe, including equipment damage, fire hazards, and electrical shock. Therefore, it is crucial to consult with a qualified electrician and follow all applicable codes and standards. The electrician will verify the high leg and make sure that the X-ray machine is connected to the right phases. Here's a breakdown of why the high leg delta system poses a risk and how to mitigate it. Firstly, understanding the high leg delta system. A high leg delta system, also known as a wild leg or stinger leg delta, is a three-phase electrical service where one phase has a higher voltage to neutral than the other two. Secondly, in a 120/240 volts high leg delta system, two phases have 120 volts to neutral, while the third phase, the high leg, has approximately 208 volts to neutral. Thirdly, the voltage between any two phases is 240 volts. Fourthly, the problem with the high leg. Many single-phase 240-volt appliances and machines are designed to be connected to two phases of a standard 240-volt supply without any neutral connection. Fifthly, if such equipment is connected between the high leg and neutral, it will receive 208 volts instead of the intended 240 volts. This can lead to malfunction or damage. Sixthly, if the equipment is mistakenly connected between the high leg and one of the other phases, it will receive 480 volts, which can cause immediate and severe damage. Seventhly, connecting the X-ray machine. To safely connect the 240-volt one-phase X-ray machine, it should be connected to the two phases that provide 240 volts phase to phase. Eighthly, the neutral wire should not be used in this connection. Ninthly, proper identification of the phases is critical. Use a voltmeter to measure the voltage between each phase and neutral to identify the high leg. Tenthly, the high leg is often marked with orange tape or paint, but this should always be verified with the voltmeter. 11thly, using a transformer. If the X-ray machine requires a different voltage than 240 volts, a transformer can be used to step up or step down the voltage. 12thly, the transformer must be properly sized to handle the load of the X-ray machine and should be installed by a qualified electrician. 13thly, safety precautions. Always disconnect power before working on electrical systems. 14thly, use appropriate personal protective equipment such as gloves and safety glasses. 15thly, if you are not comfortable working with electrical systems, hire a qualified electrician. 16thly, local electrical codes and regulations must be followed. 17thly, importance of a qualified electrician. A qualified electrician has the knowledge and experience to properly identify the high leg, make the correct connections, and ensure that the installation meets all applicable codes and regulations. 18thly, they can also assess the electrical system to determine if any upgrades or modifications are necessary to safely accommodate the X-ray machine. 19thly, alternative solutions. If the high leg delta system is causing problems, there may be alternative solutions, such as installing a different type of electrical service or using a phase converter. 20thly, these options should be discussed with a qualified electrician to determine the best solution for the specific situation. In summary, connecting a 240-volt one-phase X-ray machine to a high leg delta system requires careful planning and execution. Proper identification of the high leg, correct wiring, and adherence to safety precautions are essential to prevent damage to the equipment and ensure the safety of personnel. A qualified electrician should always be involved in the installation process. The key considerations include, firstly, identifying the high leg. This is typically marked orange and reads approximately 208 volts when measured from the high leg to neutral. Secondly, verifying voltage measurements with a voltmeter is critical to ensure correct phase identification. Thirdly, connecting to the correct phases ensures the X-ray machine receives the proper 240 volts by connecting to the two non-high leg phases. Fourthly, never connect the X-ray machine between the high leg and neutral, as this will result in an improper voltage supply. Fifthly, employing a qualified electrician guarantees adherence to electrical codes and safe installation practices. Sixthly, confirming compliance with local and NEC requirements is paramount for safety and code compliance. Seventhly, using a properly sized transformer steps up or down the voltage if the X-ray machine's requirements differ from the supply. Eighthly, inspecting wiring and connections ensures that all connections are secure and properly insulated. Ninthly, documenting the installation provides a record of the connections and voltage measurements for future reference. 10thly, testing the system after installation verifies that the X-ray machine operates correctly and safely under the provided power. By following these steps and guidelines, you can ensure the safe and reliable operation of the X-ray machine when connected to a high leg delta electrical system. Remember, it's always best to consult a qualified electrician for any electrical work to ensure safety and compliance. The potential for damage and safety hazards necessitates the involvement of experienced professionals.